Everyone, and welcome to my final presentation for the CSCI E9DB Serverless Computing course. My name is Alex Porcelain, and I've been a student in this course for the duration of the semester. I decided for my final project to explore a new set of technologies called the Elastic Stack, because in my job, I work as a security architect in a banking institution, working on implementing a variety of security controls and configurations across applications and infrastructure. As part of my role and what I've seen, logging is a critically important security control which can enable a lot of further investigation, automated rules rollout, as well as detection and alert when something is going wrong in the system. My company uses a tool called Splunk, and I'm pretty familiar with how to set it up, but I know that it's an incredibly expensive tool. It's very time consuming, requires a lot of subject matter expertise. So when I was looking into alternatives, I heard about the ELK stack. Now, the ELK stack is an acronym for 3 open source projects, each of which has their own function, and they link into each other and can be used in tandem. So I wanted to learn how to implement that. As background, the ELK stack is incredibly extensible. I was most interested in Logstash. I just like the name, but it's a server-side data processing pipeline that can ingest data from multiple sources and transform it. It sends it to a stash, and Elasticsearch is the stash for that. It's a set of APIs that allows you to actually write queries. And finally, the third component is Kibana, and Kibana is a completely built-in business intelligence user visualization platform. It allows you to turn the data that you ingested into Elasticsearch. The ELK stack was really cool, but that's actually been expanded a bit so that it's not simply these 3 components, but that there's a whole bunch of different components that the Elastic, which is a private company, has put out. Elastic itself has, again, these services, but they've introduced something called like beats, which are packages you can run on a server to actually collect the data the first time around. So you can there's an audit beat, there's a file beat, a metric beat. These would gather information. They basically install an agent, more or less, on a server or whatever other infrastructure you want, and it'll monitor and collect that data. Logstash then aggregates and processes it. Elasticsearch does what's called indexing. Indexing allows information to be more readily found and stored and connected to other pieces of data over a common index. And then, of course, Kibana is something which does a lot of the visualization for engineers. So the company Elastic has really rebranded and called these all the Elastic Stack. And the reason is because we're moving, I think, in architecture ways we've seen across the course to a place where maybe not everyone wants to use Kibana for analysis and visualization, or maybe not everyone wants to collect their data using beats. Maybe they already have existing infrastructure, or maybe they're using an SNSQ, a Kinesis, Firehose. Maybe data collection is happening into S3 buckets. So these pieces of the technology can be deployed in bits and pieces, and the Elastic Stack is incredibly extensible. I'm happy I got a little hands-on. The project I've designed is a bit simple, but I will just give an overview so that I can essentially, here is CloudWatch or CloudTrail logs, and you can configure both. I did try both. They can be written to S3 within any Amazon environment. What I've done is decided to write a Lambda function which will ingest this information into the Amazon managed Elasticsearch service, which I'll explain why I chose later. And that will be displayed by Kibana, which will also be part of Amazon's managed service. We'll use Amazon Cognito, so it's important to include that as well. And then, of course, relying on some of the fundamental services like IAM and VPC and others, which don't go into this diagram because I didn't do anything specific to configure them. So when I first started looking into Elastic, I noticed that there's multiple deployment options. One option is to use the Elastic Cloud. So I actually signed up for an account. The Elastic Cloud, it means it's completely software as a service. You can run everything that you need. I mean, obviously you have to have source data from somewhere, but you can run everything you need just from an Elastic managed endpoint. Downside is that this wouldn't be free. It's actually quite expensive for an enterprise license, but there's a 14-day free trial, which you can sign up for if you really want to do that and see if it's for you. Otherwise, you can, as I mentioned, these Elasticsearch and the other tools are completely open source, so you can just download them onto your servers. If you go on the Elastic website, you'll see there's a way to instructions for Windows, for Linux, for Mac OS X of how to download the zip files. You can run tar commands like we did in class and unzip and run them on the operating system. That just means you get away from the serverless concept. So you can use containers as well. You can run Docker image for Elasticsearch. I think you can do Kubernetes as well. But I didn't want to have to provision any EC2 instances for this demo. I could keep it completely serverless. So with that, decided to go for the AWS Elasticsearch service, which is a completely managed service. Some of the benefits of using the Elasticsearch managed service is you only pay for what you use, so you don't need to pay for an expensive trial or for licensing fees, which are based more on how much data you ingest. You'll get scalability, availability. You'll get to use IAM roles incognito for authentication and authorization. You can store any secrets that you need in existing AWS services. Your Elasticsearch resources will all get ARNs and can be configured both in the console and using the command line, or in programs using packages like Boto3 or the AWS SDK. What you really need to do, the actual configuration and the first step to create Elasticsearch domain is one of the main data structures or principles in Elasticsearch. I think in Elasticsearch, the non-AWS version, non-managed service, it's referred to as a cluster. But if you create a domain, then it'll be set up with a lot of the things you need. So you just create an Elasticsearch domain, which allows you to index and ingest data into it. You get a Kibana link pretty easy. And from there, the sky's the limit with the integrations you do. The only drawbacks I noticed so far of using Elasticsearch is that authentication is very hard to do programmatically. Even the AWS guidance, which I looked at, says you should configure all the roles in the console. So that's what I did. Logstash and Beats and some of the ingestion sides of the pipeline can't be run as a managed service. So you have to really configure that all on a server or service. And if you're not only using AWS, it may not be the easiest option, simply because you'll have to deal with all the network connectivity and permissioning, especially from the outside the AWS world. So you'll see here on the AWS CLI, what you have to start to do is create a domain. You'll see here AWS ES. ES is Elasticsearch, which is actually really confusing. You just create a domain, you name the domain, you indicate the version of Elasticsearch you want to use, and then you can go ahead and configure a bunch of details. So I didn't click in here, but you can see, obviously you can describe the instance as well in the command line, but if you want some physical proof, like I always like, you want to go in and you want to see what your domain looks like, you can do that here, and you'll see there's an endpoint for your domain, which is not accessible over the internet, but it's an endpoint that you can use for configuration. And then your scripts, when you script against this ARN, this Amazon resource number, here's my ARN with my account number in it. Oops. Well, whatever. And then Kibana, this is the dashboard that you would have to log into. So this is a good start because you've now created the resource, but you need to actually configure it to ingest data and be connected, that it's actually accessible from your Lambda, and that the ingestion points can actually be accessed so you can view. So configuring access is, this took me quite a long time, a couple hours, because each domain has its own access policy of who can actually talk to Elasticsearch. So what permissions would be required for which resources. We've seen these policies before. You can copy paste in JSON or customize it. You can choose any, the options are IP based. You can come up with an IP based policy here in JSON. That means certain IPs would be allowed to access this resource. An identity based one, right? If you have a certain role. Alternatively, what guidance was told to use resource based policy. So you define with the resources, and then you define the principal role that who would be allowed to, which IAM user. Here I put one in called the logging demo. That's not a real user that I had, but they would be allowed to access the logs. The next thing you need to do is also modify authentication for your domain. That's because out of the box, you don't even have to worry about creating Kibana instance, but you can configure a Cognito user pool using Amazon Cognito so that your Kibana dashboard, if it has some sensitive information, isn't publicly available, can rely on Cognito. Configuring Cognito for Kibana took a number of steps as well, because you need to become familiar with Cognito, but you need to add the correct users, which comes later, and set up the app client settings in Cognito itself to ensure that the user pool that you create and the federated identities all have the right permissions. You also then have to provision actual users. Cognito is cool because you can set password length requirements and all the typical Cognito functions here that you would need. One thing I noticed is that when you create a Cognito user, they always need to change their password when they log in, and password length is pretty strictly enforced, although without the greatest user interface. Then the next thing I did was create a bunch of events which would be logged to an S3 bucket. That is inherent functionality that you can have in CloudTrail, or you can set it up in CloudWatch yourself to push data to an S3 bucket. What I wanted to do, instead of having Elasticsearch ingest directly from S3 or from one of those services, it wasn't working for me. So the custom code I wrote, which is largely from an AWS instructions, so it's not super custom. I'm prepared to lose points for that, of course, although I did write this. The goal is for the Lambda that you write here in this sample.py, and I brought in a bunch of things for the S3 to Elastic Lambda function, but you want to configure your Boto 3 code in Python to go ahead and authenticate, and then set up a Boto 3 client and send the data over into Elasticsearch in the function. So you'll see it posted to a host. This is just configuring the CloudTrail watt to write to S3. So you have to change the configuration of which S3 bucket you write in the code here, or pass through as a parameter. Sorry about that. And you configure that in Lambda, and then when you run the Lambda, it should go ahead and push everything to Kibana so you can view the dashboard. So this demonstration, for its own purposes, is a bit incomplete. I POC'd it and dove as deeply as I was able to in the current circumstances. So there are a lot of visualizations and customizations you can create in Kibana, and I was able to look through a lot of the sample data. Unfortunately, at this stage, I wasn't able to ingest any of the data through S3 to make it create a visualization, but I will upload the code. And with that, I think the sky is kind of the limit with the Elasticsearch, Kibana, and Logstash, and I look forward to playing around with the APIs more and deploying in a number of different ways in a real production environment. Thanks.